Hello students, welcome to Nios Education Point. In this video, I am going to share a short TMA of physics whose code is 312 for those who haven't done their physics TMA. This is for April and October 2023 batch. So without wasting any more time, let's start. So you can see that this is physics TMA. So from question number 1, we have chosen the part A. So question number 1A is in the CGS system, force is expressed in dyne and in SI system is expressed in newtons. Establish the relation between the unit of these two systems of force. So our answer is here. The relation between the units of force in the CGS centimeter gram second system and in the SI international system of units system is that 1 Newton is equals to 10 to the power 5 dynes. Therefore, to convert dynes to Newton, you would multiply the number of dynes by 10 to the power minus 5. To convert Newton to dynes, you would multiply the number of the newtons by 10 to the power 5. So our question number 1 is completed. Let's go to question number 2. In question number 2, we have also selected part 1. So the question is, a person is standing on a turntable with some heavy weight in his hands and the table is rotated slowly. When he pulls his hand towards his chest, his angular momentum changes. Explain the change in the value of the moment of inertia. How is angular momentum converged? So our answer is here. You can see that this is how he is standing on table and rotated. So you have to write this answer. When a person holds a heavy weight and stand on a slowly rotating turntable, their moment of inertia, a measure of an object's resistance to changes in rotational motion increases. This is because the heavy weights increases the amount of mass that is further away from the axis of rotation, making it harder to change the turntable's rotational speed. Angular momentum is converged in this scenario because the total angular momentum of the system, the person, the weight, and the turntable remains constant. This is because the angular momentum of the person and the weight of combined is equal to the angular momentum of the turntable. In other words, the angular momentum of the person and weight that is lost due to the weight moving closer to the person's body is transferred to the turntable, causing it to spin faster. So we have completed question number 2 also. Let's move on question number 3. So question number 3, in question number 3 we have selected part 2. So the question is part 3b. The question is, a hawk is hovering above a field at a height of 50 meters. It sees a mouse directly below it and dives vertically with an acceleration of 9.8 meter per second square. So number 1, at what speed will it be traveling just before it reaches the ground? Number 2, how long does it take it to reach the ground? So the answer is number 1, the speed of the hawk just before it reaches the ground can be calculated by using the equation v equals to root bracket 2gh bracket close, where v is the final velocity, g is the acceleration due to gravity, 9.8 meter per second to the power 2, and h is the height, that is 50 meters. So v equals to square root of 29.850 equals to root 980 equals to 31.17 meter per second. The speed of the hawk will this 31.17 meter per second. So the next question of 3b is the time it takes. So the time it takes for the hawk to reach the ground can be calculated using the equation t equals to square root 2 into h by g, where t is the time, g is the acceleration due to gravity, that is 9.8 meter per second to the power 2, and the height, and h is the height 50 meters. So the answer will be t equals to, we can calculate that t equals to square root of 2 into 50 by 9.8 equals to 102.04 to by 9.8, that is the square root of 10.4, and the answer will come 3.22 seconds. So we have completed our question number 3 also. So let's move to question number 4. In 4 we have selected part 1, that is a man can jump 1.5 meter height on the earth. Calculate the approximate height he might be able to jump on the planet whose density is 1/4 that of the earth and whose radius is 1/3 of the earth's radius. So the answer is the gravitational force of an object on a planet is determined by the mass and radius of the planet. Since the density of the planet is 1/4 of the Earth's and the radius is 1/3 of the Earth's radius, the planet mass and gravitational force will also be 1/4 and 1/9 of Earth's respectively. Since the gravitational force acting on an object is proportional to the object's weight, the gravitational force acting on the person on this planet will be 1/9 of the force acting on him on Earth. This means that his weight will be 1/9 of his weight on Earth, and therefore he will be able to jump 9 times higher than he can on Earth, which is approximately 13.5 meters. So question number 4 is also completed. Now let's move to question number 5. In question number 5, we have selected option A, that is this. Question number 5, option A, question is using the equation speed equals to frequency into wavelength. Number 1, calculate the wavelength of the ratio signals with the frequencies. With these frequencies, A 200 kilometer hertz, B 1 mHz hertz, mz meter. Number 2, calculate the frequency of radio signals with these wavelengths. Number A 200 meters, number B 10 millimeters. So the answer is here. To calculate the wavelength of the radio signals with the radio signal with a frequency of 200 hertz kilohertz, we can use the equation wavelength equals to speed of time, speed of light by frequency. Wavelength equals to bracket, in bracket we will write 3 into 10 to the power 8 meter by meter per second, or else no, divided by 200 into 110 to the power 3 hertz. Wavelength will come equals to 1.5 meters. For the frequency of 1 meter hertz, the wavelength would be wavelength equals to 3 to the power 10 to the 3 into 10 to the power 8 meter per second divided by 1 into 10 to the power 6 hertz. That will give you wavelength equals to 0.03 meters or 30 centimeter. Now let's move to part 2, which is to calculate the frequency of a radio signal with a wavelength of 200 meter. We can use the same equation, frequency equals to speed of light by wavelength. Frequency equals to 3 into 10 to the power 8 meter per second by 200 meter. So it will be 15 into 10 to the power 5 hertz or 150 kilohertz. And the next one is for a wavelength of 10 millimeter. The frequency would be frequency equals to 3 into 10 to the power 8 meter per second divided by 0.01 meter. Frequency will give 10 into 3 into 10 to the power 9 hertz or 3 GHz, which is gram hertz. Now let's move to question number 6 without wasting any time. So in question number 6 we have selected B, option B, which is take a spring of length 30 centimeter, attach the upper end of this spring to a reed based and base and attach the pan of the lower end which has some fixed mass. Now let's let it hang vertically. Pull, release and release. Pull and release a spring by 5 centimeters so that it oscillates up and down relative to its equilibrium position. Now the pan starts oscillating in the vertical direction. Find the time period of the oscillations and the time of oscillation by using a stopwatch. Now put a weight of iron on the pan and make it oscillate. Calculate the time of oscillation from the observation. Calculate the weight of the iron using the data obtained from your observation. So the answer for this is, you can write this answer. The time period of the oscillation can be calculated by using the formula time equals to 2 radius 2 phi root square of meter m by k bracket. You will write this in brackets. This is the formula where t is the time period, m is mass of the pan and k is the spring constant. The time of the oscillation can be measured using a stopwatch. To calculate the weight of the iron, we need to use the principle of conservation of energy, and the initial potential energy of the spring pan system is equals to the final kinetic energy of the system. That is mgh equals to half mv to the power is mv square, where m is equal to mass of the iron, g is equal to g is acceleration due to gravity, h is the amplitude of oscillation, and v is velocity of oscillation. By measuring the time of acceleration, we can calculate the velocity of acceleration using v equals to h by t. We can then substitute this value of v into the equation above to calculate the weight of the iron. It is important to note that the accuracy of this experiment will depend on the precision of the measurements and the assumptions made above the system. Also, it's important to keep in mind that the weight of the iron should be small enough that it does not affect the spring constant of the spring. So our TMA is solved. Now you can copy this and get full marks, 20 out of 20. So we can end this video now, and if you haven't subscribed our channel, you can subscribe, because many TMA solved TMA is coming soon. So don't be late. Subscribe now and share it with your friends. And if you want any TMA solve TMA that you haven't done, you can comment us so we can do that also.